Hi everybody, Gary Porter again. This is the new schematic. This portion here shows the variac input and then the 120 to develop the low power supplies, then the 180 power supply, and then down here we've got the microprocessor here, my programming connectors over here, and then the motor controllers over here, and down here we've got the new layout for the board, and I gotta probably put it in a chassis. But anyway, my programming setup, the initial setup was this, my PC tied into this AVRSP converter, which goes out to COM4 port of my PC, out through the converter into this 6-pin cable, and the microprocessor is right here, and this is a spare one. And then I got I didn't have to have VCC go into this board, but because there's no connection inside that unit, you have to provide VCC. So I got a 9-volt battery and an old 5-volt power supply and an on-off switch, and so that was the first go, and that worked. So then I decided I was going to swap this guy out and then take my PC board here and substitute this in with a 120 volt connection to it, and then tie this connector here to the PC board connector. And now that with codevision works just fine too. So now I don't have to go through all this crap here of using a separate board. I can program right on my PC board just fine, and that works good. I'm using codevision, and I use DoxyCon DoxyGen to get the source file, the AVR48. And then that source file, you just simply run the compiler once you set up COM port 4 and the driver to run this device, and you're off and running, and it should work fine. The only problem, I ran into a bunch of problems, but it's all because I didn't have the driver installed and on all the other devices. But this one seems to work the smoothest. So, and it matched up with the codevision really well. Worked beautiful. So when you compile build all in the codevision, it just zips right through it. It shows you the two programmings, and that's it. So, and I checked the flash, and the flash does have software in it. So that's where we are right now. Next step is to get a motor connected out here on the power portion, 3 phases. And I got some heat sinks. I finally got them. I bored the holes for those to match in here. So the heat sinks gets bolted down, and then the fan above it will be at a slight angle, so it blows air over the heat sink for the 10 amp bridge rectifier over there for the 180 volts. And then the Hall sensor connects in here. It's power, and then the 3 Hall sensings. The speed pot, I put it at a little bit of an angle so I could. And I ran into a problem. I've got the board actually designed it with no 5 volts to one end of the pot, so I had to do some cutting and maneuvering with wires and whatever to solve that problem. So that's done. The PC board's all been updated, and that's it. Anyway, I'll let you know what happens when we run the motor. Bye.